I wanted to do a tutorial right now on finding volumes of taking a function and revolving it around the x-axis, and it's what's called the disk method. So consider this function right here, f of x, whatever the function is, between some bounds. So if I open up this, so we're going from a to b, and I want to take this function and revolve it around the x-axis. And when I do, the solid that I'm going to end up generating, is going to look something like, I don't know, something like some sort of vessel here. You see it'll be curved on the sides here. It's a bad drawing, but you get the idea. So what ends up happening is I'm revolving this about x. So the first step in doing that would be to go from a to b and partition it just like we did under when we took the first Riemann integral to find the areas. We first partitioned the interval, and that's what I did here, and drew a bunch of rectangles. Now instead of finding the area of each rectangle and summing those up, what we're going to do is we're going to take each rectangle and we're going to spin each rectangle, and I hope you can see what I did. The function's exactly the same, and you can kind of see the function hiding right in here behind there, and that's defining what the height of the rectangle is, and each rectangle gets revolved around the x-axis. Now in this case I used the 4 rectangles that I drew over here, but as we get, if I were to put 50 rectangles or 1,000 rectangles and revolve them, it would get finer and finer and be a better approximation to the actual volume. So there they are revolved. Now let's have a look at this. Alright, now let's look at just one of those rectangles. By looking at the rectangle, the height of the rectangle, which is f of x, becomes the radius of the cylinder, and the width of each rectangle, which is dx, becomes the height of each cylinder. And a pretty basic formula that we have from geometry is the volume is the area of the face, which is pi r squared, multiplied by the height. So when I look at the next layer, right there we have it, the volume would be pi r squared h, and pi is there. Playing the role of the radius would be the function value itself at whatever x value you were at between a and b, so that would be f of x squared, and the height would be dx. So putting this in terms of an integral to find the volume that we want, what we would have is this. The volume would be equal to pi, we can pull that outside, times the integral from a to b of f of x squared dx. And this would be, I think, the simplest formula when you're just taking some function and revolving it around the x-axis. So next I'll do an example to show you how this works and actually use the formula, but like I said, I don't think it's necessary for you to memorize much. This is literally just pi r squared h. So the formula is fairly simple, fairly straightforward, and fairly easy to use. Alright, so here's your example. What I want to do is I want to figure out what the volume would be if I were to revolve this function, which is the square root of x, around the x-axis, and I want to take values from 0 to 4. So the figure that I would get, if this is 4 right here, I would get this bell-shaped figure. It would look like that, and I want to figure out what that volume is. So essentially the way I do this is I look at what I call one representative rectangle from the region under discussion. Now in this case, the height of the rectangle would be f of x, the width of the rectangle would be dx. When I spin that around, it's going to make a cylinder. The radius will be equal to f of x. The height of the cylinder will be equal to dx. So I would have this, the integral from 0 to 4, pi, since it's a constant, can come out front, pi times the radius squared dx, which in this case would be pi times the integral from 0 to 4 of the square root of x squared dx, which is equal to pi integral 0 to 4 of x dx. This isn't too hard to evaluate. What you're going to have is pi times 1/2 x squared, antiderivative of x, evaluated from 0 to 4, which would be equal to pi times 1/2 of 4 squared minus 1/2 of 0 squared, which would be equal to pi times 8, which we usually write 8 pi. So that would be the volume of this solid that I have sketched out here. And this would be how you would use volume by disks method. Not too difficult, pretty straightforward. In subsequent examples, I'll show you how to do other types of problems that are a little bit more difficult, but you have the basic idea. So look back and look at the tutorial, rewind just to see what I did. This is basically redoing that.